Hi, my name is Bahadur Ahmedov. In this video lecture, we are going to discuss about the areas of circles. We'll try to derive the formula to find the area of a whole circle or some piece of a circle. So let's first of all define what is a circle. So if you've got some arrow and if you would just rotate this arrow around some axis, you would get a circle. The length of this arrow is going to be called as the radius of a circle. And one-time revolution of this arrow around the axis is going to be equivalent to the 2 pi radians. So it's equivalent to the angle, which is equal to the 2 pi radians. So now, if you would like to figure out the length, the distance which you can cover if you walk around the circle, this distance is going to be equal to the 2 pi times the radius of a circle. And essentially, if you would like to understand how much distance you can cover until half of the circle, is going to be equal to the pi times the radius. So you see, so the distance which you can cover on the circle is equivalent to the angle. So now, so let's do an example. So let's say if the radius of a circle is equal to the 10 meters, what is going to be the distance which you can cover on the circle? So it's going to be equal to the 2 pi times the radius, which is equal to the 2 times the 3.2 times the 2 times the 3.14 times the 10 meters, which is equal to the 6.28 times the 10 meters, which is equal to the 62.8 meters. So this is going to be the distance which you can cover if you walk on the circle with a radius 10 meters. So the length of a circle is going to be called as the circumference. Circumference of a circle, and the half of the length can be found by just multiplying the pi to the r. So what I want now is to find the area of the circle. So let's say you're given a circle with a radius r, then what would be the area of the circle? So in order to figure out the formula of an area, I would like to split the circle into the pieces. So let's split the circle into the 4 pieces. So let's separate them from a circle and rearrange them in this order so that it's going to look like very much or approximately as the parallelogram. So you see, so the area of the parallelogram is the multiplication of its height to the base. So you know the height of this parallelogram is going to be the radius of a circle, and the length of the base of this parallelogram is going to be equal to the pi r. Then the area of this so pi r, because this is the length of the half a circle, right? So the another half of a circle is here, right? So this is pi r. So as a sum, it's going to give you 2 pi r, which is the whole circumference of a circle. So the area of this parallelogram is going to be equal to the radius times the pi r, or which is the pi r in the square. The problem is we made this approximation by claiming that this is the parallelogram, which is not, right? So what would be better for us to see this as a parallelogram is to split the circle into the more pieces. So let's say I've got the circle and I'm going to split this into the 8 pieces. I would like to separate them from the circle, and I would like to rearrange them in this way so that it's going to look like a parabola again. So in this case, I can find the area of this parallelogram again in the same way. So by multiplying the height to the length of the width, which is going to the length of the base, which is going to be equal to the pi r, which is the half a circle, right? And again, so it's going to be pi r in the square, and it's very much looks like a parallelogram, sorry. So I would like to try to split the circle into the more and more pieces. So if I would just split this now into the 16 pieces, then I would get roughly this kind of figure. So I would like to just separate them from a circle. And please note that if this circle is given with the radius r, right, then the length of this part of this figure is going to be equal to the pi times to the radius, and the length of this side is going to be equal to the pi times to the radius as well. So I would like to rearrange them in this way, and I would like to just split them, to merge them so that I will get the parallelogram again. And please note that the height of this parallelogram is again going to be equal to the radius of a circle, and the base, or the length of the base, is going to be equal to the pi times the radius. So you see, so the area of this parallelogram is going to be equal to the pi r in the square, which is equal to, okay, so now, if you would just like keep continuing to just splitting the circle into the many pieces, you would get at the end an exact rectangle with one side to be equal to the radius of the circle, with another side which is going to be equal to the half of a circle, which is pi r. So that is why the area of a circle can be found by formula by multiplying the pi to the radius in the square. And again, for example, if you are given a circle with a radius to be equal to the 10 meters, then the area of the circle is going to be equal to the pi times the radius in the square, which is going to be equal to the 3.14 times to the 10 meters in the square, which is equal to the 3.14 times to the 100 meters in the square, which is equal to 314 meters in the square. So this is going to be the area of a circle with a radius 10 meters. So now, if you would like to figure out the area of a circle, some piece of a circle, then you can find this using the proportions. So this piece of a circle is going to be called as the sector. And let's say you would like to find the area of a sector. So the area of the sector. So the sectors are usually defined with some angles. So let's say use the angles theta. Okay? So we know that the area which corresponds to the angle 2 pi, right, one-time revolution around the circle, is going to be equal to the pi r in the square, right? And what would be the area which corresponds to the angle theta, right? So if you're given the sector which is defined with some angle theta, what is going to be this area? So this area A. So I can find this by making the proportions, right? So I need to find the A from here. So the 2 pi A is equal to the pi r in the square theta, okay? Then I can just cancel out the pi's, and I can write down the area as 1 over 2, the radius in the square, times the theta. So let's assume that this theta is equal to the pi over 4, or essentially or essentially 45 degrees, right? So if I would just substitute the 45 degrees into the area formula, and the radius, let's say, is equal to the 10 meters. Okay, so if I would just like substitute this to the formula of the area, which is going to be equal to the 1 over 2 times to the pi over 4 times to the radius in the square, which is 10 in the square. Okay, so this is going to be equal to pi r, 10 in the square, divided to the 8. Okay, so essentially it's the okay, so this is how we can calculate the area of a sectors, or the areas of a whole circles. So thank you very much for your attention. I hope that this video was helpful for you.